Hello everyone. Today we learn about the del operator. The del operator is written like this. Is the vector differential operator. In Cartesian coordinate, del equal to del over del x in direction of x plus del over del y in direction of y plus del over del z in direction of z. The vector differential operator, otherwise known as the gradient operator, is not a vector in itself, but when it operates on a scalar function, for example, a vector ensues. The operator is useful in defining in this chapter the gradient of a scalar v written as del v, the divergence of a vector A written as del dot A vector A, the curl of a vector A written as del cross a vector A, and the last one, the laplacian of a scalar v written as del square v. Each of these will be defined in detail in subsequent sections. So when we have a Cartesian, we need to do transform to the cylindrical and spherical. So using the previous formula transformation method, so we can get that the cylindrical coordinate is like this. Del equal to del over del rho in direction of rho, del over del v 1 over rho in direction of v, del over del z in direction of z. Same with the spherical coordinate. We use the transformation method and we get the final answer. The final equation is del equal to del over del r in direction of r, del over del theta 1 over r in direction of theta, del over del v 1 over r sin theta in direction of v. Okay, let's see the gradient. What is the gradient? The gradient of the scalar field V is a vector that represents both the magnitude and direction of the maximum space rate of increase of V. So del V, or we call it dV, dV equal to del V over del X dx, del V over del Y dy, del V over del Z dz. So we can expand this. Del V over del X in direction of X, del V over del Y in direction of Y, del V over del Z in direction of Z. When with the dot product, so same direction equal to 1. So del V del X times dx, del V of dy, del Y times dy, del V of del Z times dz. So for convenience, let G equal to del V over del X in direction of X, del V over del Y in direction of Y, del V over del Z in direction of Z. So we can simplify the equation like this. dV equal to G dot dl equal to G cos theta dl. This is the illustration of the gradient of the scalar. So the gradient is, this is for Cartesian, this is for cylindrical coordinate, and equation 3.30 is for spherical coordinates. The good news that in examination or test, the equation is in appendix and you just want to know how to use this equation. So don't need to memorize, just use the equation. So look the example. So find the gradient of following scalar field. So V equal to E equal to exponent negative z sine 2x cos y u rho square z cos 2 phi for C W equals tan r sine square theta cos phi. So from the equation of the gradients, so we can see that 2x and y is a Cartesian. So we can find the formula del v equal to del v over del x in direction of x, del v del y in direction of y, del v del z in direction of z. Means that you differentiate the v. Okay, you differentiate the v based on the direction of x. So dv dx. So you differentiate of the x. So 2e exponent of negative z cos cos 2x cos y in direction of x. Same that in the direction of y and direction of z. So for the second one is, you can see that they have a rho, z and phi. So of course automatically you know that this is the cylindrical. So the cylindrical, so you choose the equation of the cylindrical. So at the rho, del u del rho, so you differentiate at the rho part, and phi you differentiate at the phi part, and z you differentiate at the z part. So a W is a spherical because I have R, theta, and phi. So you differentiate the R part, and this is a differentiate of at the theta part, and phi you differentiate at the phi part. Divergent and divergent theorem. What is a divergent? What the difference with the gradient? So the divergence of A at a given point P is outward flux per unit volume as the volume shrinks about P. So divergence of A. So divergence of A means that divergent to the vector. So gradient is a divergent to the scalar. This is different. Is a gradient is a differential to the scalar. You can get the answer is the vector have a direction, but for the divergent is a differentiate with the vector. Let's see. So divergent A also we can solve it through the integration. So the cos integration of A dot ds divide the differential of b with a limit of differential of b approach to 0. So illustration of divergence of a vector field at P. A is a positive divergence, means they go upward, and B is a negative divergence, go inward, and C is the zero divergence. You can see here, when you use the integration, it takes a lot of time, a lot of calculation and complex calculation. So it takes a long time. So how to reduce this a lot of the integration step? So we use the divergence. So we introduce the divergence. We can see that divergence is a simple instead of the integration. So that's why we use the divergence. So in Cartesian, divergent A equal to divergent vector x, del over del x, differential of vector x, differential of vector y, differential of vector z. Same with the coordinates, spherical coordinates, and also the spherical coordinates. But the following properties of divergence of vector field, it produces a scalar field. If gradient, the differential to the scalar, we can get the vector. So the final answer gradient is the direction, but the divergent, the final answer is a scalar. So divergent A plus B sama dengan divergent A plus divergent B. Divergent VA V divergent A plus A dot divergent B. So what is a divergence theorem? Divergence theorem states that the total outward flux of vector field A through the closed surface S is the same as the volume integral of the divergent A. So maksudnya flux yang mengalir keluar daripada vector field A melalui kawasan tertutup S adalah sama dengan volume integral volume isi padu of the divergent A. So let's see the example. Determine the divergence of this vector. So first is the Cartesian coordinate. So we see that del over del x at the vector P. So vector P, so del over del x, x square y z. So del over del y and vector y. So here is vector y is no vector y here. So no vector y. So we say that we put the 0. So del over del z rho z. So we can see that at the vector z. So del over del z x z. So x, so 2xyz plus dengan vector z, z differential is 1 is plus x. So we can see the differential is the same for the differential for the cylindrical. So we can see that 1 rho del over del rho rho q rho. Q vector pada rho. So you tengok vector pada rho ada rho sin phi. So pada phi rho square z. Pada z is z cos phi. Sama juga dengan spherical. So you can follow this step. You can see here when you use the integration, it will take a lot of the calculation instead of the differential. So divergent is used to improve or to solve the solution when we solve using the integration. Curl of a vector and Stokes theorem. So when we talk about curl, it's a cross product and it related to Stokes theorem. So the curl of A is an axial or rotational vector whose magnitude is the maximum circulation of A per unit area. As the area tends to 0, whose direction is normal direction of the area when the area is oriented to make the circulation maximum. So this also to improve the step, so to reduce the step or to improve make the solution is fast. So from the integration we can see it's a complex solution, complex step. So we introduce the curl method. So the definition is curl A. Curl A means that is a curl A means that del over del x, del over del y, del over del z, ax, ay, az. So you use like this. You arrange the direction of x, direction of y, direction of z. So dx, del over del x with the vector x, del over del y with the vector y, del over del z with the vector z. So del az divide by del y minus del ay divide by divide by del z. So you close one side, del time az minus del time ay dz. Same like this. And then the second one at direction y, you close the middle line, middle column, and del time az over dx plus del time ax over dz. So it's the same. And also this also. So you use this method to find the curl A. Same as with the coordinate system and spherical coordinate. So, but this is not necessary to memorize. Instead, I'm not uh, encourage you to memorize, but you need to know how to use, how to differentiate, how to to cross the product, del cross A, or how to curl the product to get the answer. Or this is a property of the curl. The curl of a vector field is another vector field. So you can see the properties of the curl. So del cross del equal to 0. Del cross del B equal to 0. So from the example 3.6, you can change to the method curl, and then you do the method del cross P, del cross Q, del cross T. So using the equation here or in the appendix, uh, you can find the solution. So you find first, for example, del cross P is a del over del y at vector P at the direction z. So del cross del z vector P at the direction y, and so on. The last one is the laplacian. So the laplacian of scalar field B written as del square B. E is the divergent of the gradient of B. So this is combination divergent and gradient. So del dot del B equal del square V. Otherwise, we say that del over del x in direction of x plus del over del y in direction of y plus del over del z in direction of z. So after derivation, we got this for Cartesian, this for the cylindrical, and this for the spherical. So you need to know how to use. So find the Laplacian of the scalar field of example 3.3. So take the formula Laplacian. So like del square del x square. So you need to derive two times. So first you derive b for derivative, and second derivative you need to get the answer. That is a Laplacian. Clarification of vector field. A vector field A is set to solenoidal or divergentless, or if like divergent A equal to 0. So divergent A equal to 0, curl A equal to 0. Divergent A not same as 0, curl A equal to 0. Divergent A equal to 0, curl A not same to 0. Divergent A not equal to 0, curl A not equal to 0. There has four properties in the clarification of vector field. So another one is a vector field A is set to irrotational, means that curl A equal to 0. That's all for today.